This is the Commodore PET 4032. The PET, or Personal Electronic Transactor family of computers, was released by Commodore in 1977 and represented their first foray into the computer market. Previously, Commodore had been known as a calculator company. The 4000 series was released in 1980 with a 9-inch screen, and 12-inch screen models were released in 1981, and that's the model we have in front of us today. The case of this machine is date marked to May 1981. However, the mainboard has a variety of chips from the second half of 1983, indicating that this particular unit must have been put together after that date. This machine is owned by a colleague of mine and has been on display at our place of work for several years now. The owner reported that the last time the machine was powered on, the screen displayed a significant wobble, and the majority of keys on the keyboard did not register key presses. However, at this point in time, the machine was entirely non-functional. So I offered to take a look and see if I could repair the machine. This particular computer had been imported from the United States and expected a supply of 117 volts at 60 Hz. Now, this is significantly lower, yet faster than the power used in the UK, where we have a nominal 230 volts at 50 Hz. So the first thing that needed to be done was to check the power supply. As you can see, the machine is now operational. So let's take a little look in the side so we can see what I did to bring the machine back to life. As you can see, the PETs have a wonderful feature allowing you to prop the machines open. Once I'd completed my visual inspection, I went ahead and removed this connector here, as well as the one at the end of these two brown wires that go inside the display to provide power to the CRT. This allowed me to check all of the voltages coming out of the transformer, but on checking them I found there was absolutely nothing there. And that's because there was no input voltage at all. This prompted me, of course, to check the fuse, and we can see why this might have been a problem. You can see here that the fuse is entirely blown, it's quite blackened and charred, and is actually broken in two places. Now, this particular model has an IEC connector on the back, and when I received the machine, no power cable was connected. As the machine was on display and accessible in a commercial premises, it actually has a number of PAT test stickers on the back of it. Now, for the uninitiated, a PAT test is a portable appliance test, and although not legally required, is a de facto practice here in the UK. These are carried out by plugging the cable into a PAT test device and making sure that it complies with the relevant electrical safety standards. Now, these testing devices have a UK socket on them, and so that implies at some point this machine had a IEC cable with a UK plug on the end, and I surmise that that may have been plugged directly into 240 volts, blowing the fuse. Now, fortunately, the machine itself survived that experience. I went ahead and installed an appropriate brand new fuse and connected the machine to a 120 volt supply. This allowed me to check the voltages on the transformer, which were all in spec. As rectification and regulation is actually carried out on the main board, at that point I had to reconnect the power to the header just here and the similar one inside the display cabinet. While all the voltages on the main board were present and correct, unfortunately the wobble on the display, as indicated by the owner, was also present and quite severe. And as anticipated, a quick tap on the keys indicated that most of them were indeed non-functional. As you can see, this particular machine uses the universal mainboard and so could be converted to 80 column mode. On the left hand side you can see an extremely large reservoir capacitor, and that isn't original to the machine. This capacitor is a British made one from RS. While PETs do include a reservoir capacitor, they're usually much smaller in size. As it happens, I wasn't the first person to work on this machine, and so I believe that the reservoir capacitor change was an attempt to resolve the screen wobble I've already mentioned. Behind the capacitor you can see a modern switch mode power supply, and this replaces the original transformer that was in the unit. This is that original transformer. The PET uses this to step down the incoming 117 volts to the appropriate lower levels required for the various components on the machine. Now, transformers are usually configured to cope with a particular frequency of operation, and this was designed for a 60 Hz system in the US, but was being used on a 50 Hz power supply. This will result in increased magnetic flux, which affects nearby devices sensitive to magnetic fields. Notably, the PET includes a built-in CRT monitor, which is of course very sensitive to magnetic fields. One typical way of testing whether or not the transformer is causing display distortion or wobble on the screen is to operate the machine closed and in this propped open fashion. If, as you change the angle of intersection with the field, the display artifacts change, it's likely you have magnetic interference. The original transformer has a particularly severe output at 50 Hz, and so the effect wasn't immediately obvious. However, after careful inspection, I was able to identify a small change in the behaviour of the display, which indicated that the transformer and magnetic interference was the root cause. One way to reduce the magnetic interference from a transformer is to add a copper band around it. As a gross oversimplification, this interferes with the magnetic field and essentially nullifies it. After some further discussion with the fine folks from the Vintage Computer Federation forums, I resolved to install a copper band on the transformer, and you can see that is done right here. So the recommendation is 0.6 to 0.8 millimeters, and knowing that the lower the frequency, the thicker the copper band needs to be, I went ahead and actually installed a 1mm band here, and it's important that you solidly solder it, as you can see here, which took quite a lot of effort on a large transformer with a 1mm copper band surrounding it. But eventually I did get a good electrical connection and reinstalled this in the machine. This did result in a significant reduction in the wobble, and in fact from a distance it was mostly imperceptible. However, up close there was still a significant wobble and it was quite distracting. There are some additional steps that I could have taken and were discussed on the forums, such as installing a bucking transformer to reduce the input voltage and therefore reduce the strength of the field. Alternatively, you could use a variac to carefully control the input voltage. However, as this machine is not owned by me and will likely be used in interactive exhibits that may move around in the future, anything that was dependent on particular voltages or required careful configuration didn't seem appropriate. At work, I'm fortunate enough to have a variety of high-spec bench power supplies at my disposal. So, as an experiment and demonstration, I went ahead and set up a configuration of supplies that provided all of the required voltages into the machine. After some brief discussions with the owner, they settled on the installation of a modern switch mode power supply. As this power supply accepts a wide range of voltages and frequencies, that means this computer can be used directly on main supply, essentially anywhere in the world. I've modified the supply to provide the required voltages in via the existing header here and via the existing cables into the monitor cabinet. This means that power regulation is carried out via the existing circuitry on the main board. The supply itself is retained in place using a 3D printed bracket, which is affixed using the original fixing screws. This approach was taken to ensure that all of the changes I've made are as reversible as possible and allow the owner to revert back to the original transformer if they choose to do so in future. Before powering up the machine with the new supply, I decided to take a closer look at the main board, and this was just to ensure that no debris from this installation was affecting the board and was likely to short anything out. However, on closer inspection, I did notice an anomaly with the 6502 processor at the heart of the machine. As it turned out, one of the pins was bent on the processor and was not making contact with the socket. In this photograph, I've lifted the CPU slightly to highlight the issue, but I haven't actually removed it from the socket. And you can see this pin is not making any contact, and it was not doing so when it was fully seated either. Now, interestingly enough, this is a ground pin on this version of the 6502, and the chip has another one on the other side. Nonetheless, I decided I should bend that pin back into shape and have now seated the processor correctly in the board. On powering up, the display was now perfectly stable. However, some of the text was very slightly off screen at the top of the display, and so I went ahead and adjusted the whole drive to bring that in line. With the display problem now resolved, the next issue was the keyboard. The keyboard on this PET has plastic stalks with an inverted rubber dome on the bottom. In the centre is a carbon pad, and this connects two interleaved contact traces on the PCB. Over time, the resistance of these carbon pads increases, and this is a common problem with this type of keyboard. To resolve the issue required fully disassembling the keyboard and ensuring that every single carbon pad had a contact resistance of below 100 ohms. This was achieved by resurfacing the carbon pads by gently abrading them with regular printer paper and, where necessary, applying carbon contact restorer. A previous repair attempt on the keyboard had apparently applied some kind of contact cleaner or lubricant to the keyboard. Unfortunately, this has resulted in some scarring and damage to the underlying plastic supports, and this means that even though I've cleaned the keys, some of them are slightly more liable to jam. To reduce this, I went ahead and applied a plastic-safe PTFE dry lubricant, and this has alleviated the sticking to a large extent. Finally, the machine itself was missing its fascia sticker, and while a cardboard replica had been affixed, it was peeling, tatty, and of the incorrect size. As there is some significant scarring to the plastics in the label area, for the time being I've applied this paper label with a water-based glue. I intend to replace it with a professionally produced reproduction sticker in the near future. As you can see, the machine also comes with an early example of a C2N cassette unit. While these were often referred to as the Datasette, this particular unit is indeed marked with the word cassette. On receiving the cassette unit, it was also non-functional. However, this turned out to be a minor issue with one of the power connections inside, and this was easily resolved. Closer inspection has shown the belt to be in good condition, so it hasn't been replaced, although the head did require a gentle clean. The record functionality does produce a good, clear and strong signal. However, the playback and decoding mechanism is quite sensitive to the correct levels and is not particularly robust against noise. Notwithstanding that, I was able to take a few D64 disk images and PRG format programs, convert them to the appropriate waveforms, and copy them onto a vintage TDK PC15 audio cassette. So let's go ahead and load one of those programs. We can go ahead and type load on the keyboard. To begin the load, we press return. One nice thing about the PET is that it has some limited sense and control capabilities over the cassette unit, so the machine is able to tell us we need to press play. The computer has now finished loading the program and has automatically stopped the cassette unit. While the play button remains depressed, the computer can automatically restart the cassette unit to load more data. In this case, we're done loading the program, and we start it by typing run. This program starts with some additional instructions. It shows how the program can produce, and you can receive, additional sound effects. This game is Space Invaders. It was released in 1980 and has this really neat animation that introduces the game. The demo screen shows how the game works, and it's probably going to do a much better job than I am. You control the game with the 4 key, the 6 key, and the A key. The game shows another neat animation. So let's get started. Shouldn't have taken my hands off the keyboard. I'm going to need a lot more practice. However, this machine is now fully operational, so I should probably return it to its owner. Fortunately, I can continue practicing my Space Invaders on the Commodore PET by using a web-based emulator, and I'll provide a link to this game and that emulator in the video description. Why not tell me your high score in the video's comments? But for now, I hope you found this video about the Commodore PET 4032 interesting, and I hope to speak to you again soon in the next one.